Alright, welcome guys. So in this tutorial, we will see how we can figure out the network address, the broadcast address, the first usable host, the last usable host, and then the number of usable hosts within that network address given an IP address and its subnet mask. So the IP address is an address that's been assigned to a host within the network, and the subnet mask is what that what will tell us how many bits within this IP address is our network bit and how many bits is our host bit. Alright, so let's see how we can go about it. First thing to do over here is let's first look at the IP address. It has 4 portions and each portion corresponds to a 8-bit binary number. So 10 will be represented by using an 8-bit binary number, 100 an 8-bit binary number, 20 and 180 will also be represented by 8-bit binary numbers respectively. So 8-bit plus 8-bit plus 8-bit plus 8-bit, a total of 32-bit will be used to represent this IP address. Same for the subnet mask. So let's just first lay that out. So the binary for 10 in 8-bit binary number representation would be 00001010. Right? So the binary for 100 will be 01100100. Right, the binary for 20 will be 0001 0100. Right, and the binary for 180 will be 1011 0100. Right, so that is basically the 32-bit representation of this IP address. Right, so now what we will do is write the binary representation of the subnet mask, which is 255.255.255.240. Now the binary for 255 is, that's just all ones, 1111 1111. Right, once again we have another 255 over here in the second octet, so that's another 1111 1111. Right, so in the third octet we once again have another 255, so that's 1111 1111. Right, in the fourth octet we have 240. Right, so the binary for 240 will be 11110000. Right, so that's the binary representation of the subnet mask. Now what we have to do is carry on bitwise ANDing of these binary bits one by one. Right, so let's just go about that. So if we AND 0 and 1, so the AND operation will only give you a 1 if both the bits are 1, and if any or both of the bits are 0, then this binary ANDing operation will give you a 0. So 0 1 is 0. Once again we have another 0 1, so it's 0. Then we have 0 and 1 here, so 0. Another 0 and 1, so 0. Then we have 1 1 here, so carrying out the AND operation will give you a 1. We have 0 and 1, so that's 0. That's another 1 there and 0. Right, so if you see over here, let's just inspect this a little bit. So in the first octet we had 00001010, and if we ANDed that with all ones, we ended up getting what we initially had. Right, we ended up getting 00001010. Right, that's what we just had initially. So similarly, we do this ANDing operation in the second octet, 0 1 0 1 1 1 1 1 1 0 1 0 0 1 0 0. So once again we ended up getting what we just had initially. Right, so let's just in the third octet we have once again all ones, so we can pretty much guess what's going to be just what we initially had, 0 0 0 1 0 1 0 0. Right, but in the fourth octet we do not have all ones, so there might be few changes in our output. Right, so we have 1 1, that's going to be a 1, we have a 0 1, that's going to be a 0, we have another 1 and 1, so 1, once again 1 and 1, so 1. Then the rest of the 4 bits is going to just be 0. Right, so now if we just write the decimal representation of this, we will be getting our network address, right? So 0 0 0 0 1 0 1 0, that's just 10. 0 1 1 0 0 1 0 0, that's 100. Right, this one, the third octet is just going to be 20. The fourth octet, that's going to be 176. Right, so this is going to be our network address. I can just write down here our network address is 10.100.20.176. right, so another thing to do, guys, let's look at this subnet over here. So in the subnet mask we have all ones in the first octet, all ones in the second octet, all ones in the third octet, and only 4 ones in the fourth octet. So the prefix max for this will be the number of ones that we have, right? So this is 8 plus 8 plus 8 plus 4, so that's going to be 28. Right, so what this subnet mask tells you is a total of 28 bits starting from left to right is going to be in our network portion, right? And the last 4 bits is going to be our host bits. So once again, the first 28 bits is going to be our network bits, and the last 4 bits is just going to be our host bits. Right, so we get the broadcast address when we set all the host bits to 1. So this 4 bits over here, these are our host bits, right? So I will get my broadcast address when I turn all my host bits to 1s. So if I do that, what I'll be getting is 00001010.011 00100 dot 00010100 dot 10111111. Just turned all my host bits to 1s. Right? So now if I write the decimal representation of this, it will be 10.100.20.191. Just doing the decimal representation of this, right? So I'm just going to write my broadcast address. It's going to be 10.100.20.191. Right, so my first usable host is the address that's immediately after my network address, right? So in other words, it will be when I turn this very last host bit to 1. So if I write it like 10110001, that's going to be my very first host address. The rest of the portion stays the same. So my very first usable host is just going to be the address immediately after my network address. So it's going to be 10.100.20.177. So my last usable host is going to be the host that's immediately before my broadcast address. And if we look into our broadcast address, the address that's going to be immediately before my broadcast address is just going to have a 0 in this very last bit. So it's just going to be 1 0 1 1 1 1 0 1, sorry, 1 0, right? So if we just write the decimal representation of this, that will be 190. So that's the address that's immediately before my broadcast address, right? So it's just going to be 10.100.20.190, right? So if we're done with that, what we can look into now is how many hosts can we accommodate using this network address, right? So if you think about it, the network address and the broadcast address, right? We cannot assign this to any particular devices, right? But everything that's between the network address and the broadcast address, we can give to any host. So the host bits we had over here, we had 4 host bits, and these host bits can be written, since we have 4 host bits, so it can have a combination of 2 to the power 4, right? So that's 16 combinations. But when the host bits are all 0, that's just going to give you the network address. And when the host bits are all 1s, it's just going to give you the broadcast address. So 2 of these addresses we cannot use. So the number of usable hosts will be 16 minus 2, which is just 14, right? So the number of usable hosts will be 14. So that's about it, guys. I hope it helped you understand the problem a bit, and thank you for watching.